All right, welcome everyone for today's OTT. Today we have an interesting topic. We're going to talk about SST. I'll start by providing you a general overview. I'll show you like the killer features, which I think make SST quite interesting and a big advancement for the infrastructure as tool codes that we have in the market. And then I'll show you a more hands-on application. So it's a little bit of a demo where we can take a look at some code. And at the end, we can have a discussion and see what everyone thinks and answer any kind of questions. So just to get started on the pretty general killer features that SST brings to the table, the first one has to be Lambda debugging. That's something we're going to see in this presentation, where it really helps and it speeds up the development lifecycle when developers can start their own stacks into an AWS account in a way that Lambdas are a bridge to their own personal computers. So this allows for developers to actually debug Lambda invocations and have all the features that they're used to when developing more monolithic application or microservice that they run in their own computers. So it really speeds up and improves the development life cycles compared to tools that don't give that kind of feature. And the developer has to wonder how they're going to test their Lambdas, and maybe they have to go through some hoops to manually create Lambdas in AWS, and it's a little bit of a pain. And this is a really nice feature. I also want to mention that it's CDK extensible. So when you're writing SST, it's not like you're just writing serverless applications and then you're stuck with the serverless model. So if you want to create a database or a VPC, it's like, no way. That's not actually a blocker, because you have access to CDK, which is very close to CloudFormation. It generates CloudFormation. So that just means that you can have CDK stacks that create VPCs, databases, ECS clusters, anything that you're used to create with other tools. You can also use CDK to do together with SST. Also want to note that there's really good documentation, which, as we all know, when we're using AWS, it's usually complicated to go through the docs and find everything you need. But if you're just starting out and you want to get something up and running, you get some pretty good examples in the docs on how you can get started. And later you can, like I said before, extend your CDK. So you can start off pretty simple, and slowly you get exposed to more AWS resources. This is pretty nice also to learn AWS. There's so many services and so many things to study that it can be overwhelming for developers. So if you start with a tool like this, developers can start using queues and lambdas and services that are more well-known, and then slowly get more in touch with the other things that AWS offers, which help take applications to production. And the last thing, which is something that I personally really like, which is the language server autocomplete. This is something that I feel that lacks in many other tools when compared to CDK, which is you don't have autocomplete. If you go into a file, you don't know actually which fields are possible to use. So for example, if you create a queue, which properties are you allowed to pass in? For that, you have to go into the docs, you have to search through, you have to see what you're going to pass. And using SST or CDK, you have all the features that developers are used to, such as a language server that just gives you autocomplete saying, hey, you can pass in a VPC ID here, you can pass in a cluster here, and it really speeds up the time that it takes for you to build things. And I do want to make also the connection that these things go hand to hand with the well-architected framework. In terms of, I would say, operational excellence. This means that if you have operational excellence, it means that you actually can build tools with confidence and speed. And this is really allowed by this set of tools. And you don't actually lose many of the things that you usually do when you pick tools that do too many things for you. And like, if it gives you too much abstraction, usually takes away the power that you have to customize, which is not the case over here, because you still have access to CDK. So in terms of security, reliability, efficiency, all the things you still get when it's time to take things to production. Now, let's stop giving just an overview, and let's actually look at an application, look at some code. And this architecture is what we're going to be looking at. In a high level, this application has 2 AWS accounts. So it's not a very trivial example, because we are having an infrastructure account and a workload account. In the infrastructure account, we're going to have CDK resources that create basically the networking. So the VPCs, the private subnets, internet gateway, net gateway or net instance, all the NACL rules. That's going to happen in a specific account. And that account, using the resource share of AWS, is going to share with the workload accounts. It's going to share the subnets. So that means that if developers are working in the workload account, they're not exposed to the lower level infrastructure that should be handled more by the DevOps team or the team that takes care of security and audit. There's a better separation of concerns there. And AWS has a bunch of recommendations in that sense. This is the first step, right? And then to take steps further, you can have accounts for doing logging, doing backups, and so on and so forth. But we're going to start looking at infrastructure and workload. There's a couple CDK constructs that I can show you for this account. The ones related to SST are all in the workload account, where we have an app sync that forwards messages to EventBridge that puts them on a queue. And this queue is consumed by an ECS application running on Fargate. And this has a long pooling of 20 seconds, which is the max. So it really tries to do a job of not calling SQS in a short pool, which consumes more resources. It's just going to do its best to collect as many messages in a single request and do the job. And once it finishes this, I won't be able to show you because it's not finished, but in the final implementation, the ECS task would call a mutation in AppSync, which generates an event for the frontend, which could be subscribed here. So you get a full API going here. All right, let's take a look. Since I spoke to you about the infrastructure, I'll quickly go over this. So just for you to start seeing CDK code, this is how you create a VPC. You pass in the IP addresses that you want to have. By default, it's going to create a net gateway for you, but that's going to cost around more than $30 a month. So if you're doing development, what I prefer to do is create a net instance, very small, and pay for the savings plans. So it becomes like $2 a month, which is great for saving costs for development. But once you take to production, you can have a kind of a rule here in CDK, because this is just a code. So you can have an if else or something like that, where you don't specify a provider. So it knows that, okay, you want to create a net instance. And beyond that, you have the subnet configuration. This is very interesting. The VPC gateways for S3 and Dynamo, they allow you to communicate from inside your VPC via a route table address in your subnet directly into these 2 services only. And that means it's both free because it's just a route in the table. And also it doesn't take the data outside of your VPC to get to S3 and Dynamo. So you don't have like extra networking charges for going outside of your net gateway into the public internet back into AWS. So it's much more straightforward, cost efficient, and secure doing this way. And what's also interesting is that these details are not exposed for developers. So you could set up this in the infra side, set up an infrastructure account, share those subnets with the workload accounts, and developers just need to deploy their tests into this VPC, and they don't need to worry, how am I going to reach S3 or Dynamo? It's going to happen under the hoods. And if you need to access other types of services, then by default, you're going to have to go through the public internet unless you pay for an interface endpoint. So there are many options that are going to depend, of course, from architecture to architecture. Let's jump over now to, let me see. I can show you the actual application that we're going to be doing. There is over here a very simple front end, and we're just going to start making calls. So for us to log in, we're going to be using Google. And right now, I already have SST running in this terminal here. I can show you here. I ran a npm run debug, which in my package JSON runs SST dev, which with an increased timeout and inspect. So this means that I have my own stack in AWS, and I'll start a debugging session. My debugging session is already running. So what I'll just do is show you the debugger that I have over here, and I'll start to log in. Now, okay, we got to choose our account to log in. I want to pick one. And here we go. Now our front end is showing our token here, and it also created for us into this animal table the row. Let me just check, because it sucks to do it live, but I need to re-enable this auto attach thing here. Our debugger didn't catch it. I love doing things live because you never know what's going to happen. Let me try. Okay, we're gonna have to stop this, and because I have to show you the debugger session. So let me toggle this to always and start the session here. Okay, it attached, but we're gonna have to first assume the account, so we have the credentials to get into it. Now let's run npm debug. Okay, the debugger attached. That's good. Let's see if now the breakpoint is going to activate. Okay, let me run that again. See, I deleted here again because I wanted to show you the creation. Right, awesome. Happy that I could show you this. So finally, we got our debugger here. You actually get to see and walk through the stack of calls. This is the Dynamo client, which is going to put the user into this table. So let's do that. We step through, and if we scan, there we go. We got the user created here. And once we let it complete, the front end should be able to complete, but it took too long. So it's not happy that we are debugging. So let me not debug and just let it complete quickly. Okay. All right, so we got our login working. We were able to debug, and now we can continue testing the rest of the architecture where we connect to AppSync to do all these processes. So let's do that through the SST console. But this time, I'm not going to use my like developer stack. So let me stop this one. I don't really have to, but I will. And now what I have running here is npx SST console stage dev. What this means is that I'm hooking up my SST console to the dev stage. Previously, I was hooked up into my own personal stage. Now I'm hooking up into dev. Dev is a stage that is deployed, so it's not something that I can have debugging into. I can only debug my own personal stage. So let's use this console here that I have in a different tab right over here. As you can see here, it's going to change. Let me show you the difference. Here you can see it's my last name, first name. That's my personal one. And here I have the dev version. So I can have both of them running at the same time. It's okay. So as you saw before, Dynamo created, let me restart this 1 sec. So as you saw before in Dynamo, we created a record using my my personal stack. And now we're going to do in the dev stack. Let me copy that exact URL that we passed there. Yes.
I have a question. Not sure if I need to wait to the end.
No, go ahead.
That local stack is an abstraction in your local computer, or is a local stack in Amazon?
Let me show you. It's a stack cloud formation. It's a stack right into the dev account that you have for your developers.
Oh, okay.
Let me show you here. You have the dev workload and you have your personal workload. So each
perfect.
developer gets their own.
Okay, nice. That is an issue, usually, having all the Amazon services into a local environment so you can interact with it. Okay, nice.
Yeah, what this allows you to do is like a developer can have their own stack, do their modifications, while another developer does their own feature, and there's no collision. So I have my own data, you have your own data. It's very interesting. All right, let's continue here, taking a look at the console that I have open for dev. So what we want to do here is test the full integration. So here I have the GraphQL API. And here, I don't have this running on my local host. I actually have this on Vercel. So I can actually test this in a deployed environment. So let's do a login. I'll log in again. Here I got my token, I'll copy it. And as you can see here, my user got created into the Dynamo table that is in the dev stack. And let's go into GraphQL. Let's do a hello OTT. Let's paste in our authorization. Now let's make a call. It is very quick. Since we're calling event bridge, we get the event bridge ID. And since this is GraphQL, we can just, again, have autocomplete to know what my API is exposing, so we can request everything if we want. And let me show you right now, how can we actually visualize all and observe how all these things are happening in our infrastructure. For that, I'll open up X-Ray. And here you can see that X-Ray is picking up some interesting things. Let me do an update over here. And so what we got here with X-Ray is the full visualization of the architecture we saw in the beginning, where we have a background runner, which runs on an ECS container. If we prefer to see the metrics instead of the icons, we can see that it takes on average 20 seconds, which is our pooling time, which is expected. We're pooling every 20 seconds. And events, let's see here. Here we're processing the message inside the SQS container. We're getting the messages from SQS, which has a relationship here with EventBridge, but unfortunately, I have to do some extra setup to see SQS. Right now, we cannot see it. But if we go into view traces, we can actually see the trace that we just created. So by looking at the trace, we can inspect like the metadata of the process message. And we can see here in the metadata that we have our hello OTT, which is the data that we sent. So not only can we see and inspect data if we want, we can also see where we may have bottlenecks in our application. Right now we can see that there's an overhead to having EventBridge here, even though EventBridge is really nice for us to do an event-driven architecture. We still have an overhead of like 50 milliseconds for having it in between our API and our ECS container. It may also be the case that this includes the time that it takes to SQS to process the message, which is very short, but this is something that you need to ensure that it's the right service to use for your specific use case. Sometimes it is. Sometimes you have to do is go directly to Dyno, for example. This is going to be the shortest path to go from AppSync to Dyno and get a response in the front end. And this way, if you need to do some like react to an event, you can have Dynamo streams, and then you can put whatever you want into AWS and process the message async. Yeah, I think this covers all the topics that I wanted to show you. I also had here the documentation, but yeah, this is a tool that I've been exploring quite a bit for the past couple of weeks, and just doing this demo and a couple POCs. I've been having a lot of fun with it. So thank you for joining this OTT. Let me know if you have any questions. It's a good time for us to talk about
I have
the
a question.
tool. Yeah.
Maybe it's not about SST, but how you made the X-ray work on ECS, if that is what you have done, and can you show us that code and how the autocomplete works there for the I don't know if CDK or SST in that case.
For sure. That's a great question. I think we should have an OTT only about X-ray. It's
Okay.
it's an incredible thing. But in any case, let's take a quick look. So I have a bunch of repositories just for this demo. One of them is, let me see, this one, the workload AI. This stack right here is responsible for creating the ECS cluster. So at the beginning, we declare our image, which is the Docker file that we want. What's the platform? Here I'm using ARM. That's the architecture of my computer. Here also, I was going to show you, you can even do calculations. You can do anything with CDK. And let me show you the autocomplete. So in case you're just creating a container, you don't know anything about it, you can just take your mouse over, click on it. You can check, okay, CPU, what is that? Okay, how much CPU the container requires, memory. You can see how much memory container requires, traffic port, what port it's used on, image, the image to run. And of course, you also have, because you're using TypeScript, you have type checking. So if you're passing a string where it expects something else, you get a compilation error that you have to fix. This is much faster than doing something wrong in a YAML file, building it, and then waiting for it to process, and then seeing the error, then, okay, I was using a string where it needs to be an integer, then you go and fix it. This way, it takes away some of that time that you spend there. And here you can see other things. Container can also have secrets. You can see them here. Again, let's see, this is going to expect sequence environments variables passed to the container. There we go. About X-ray now. X-ray is, because I'm using a CDK construct, this is not SST, but it can be used together. They're all the same thing, basically. And I'm using ECS service extension, which allows you to create an ECS cluster in a very simple way. And one of the things that it gives you is this X-ray extension. What this does is, in the same ECS task that you create, it adds a sidecar, which is another container inside the task with an X-ray daemon. So when you hook up, and I have some Python code that I can show you, you patch your AWS SDK, and it intercepts every call that you make to AWS, makes that it first sends a login to X-ray, then it calls the service that you actually want. So that means that any interaction you do when you delete an SQS message, you get that nice trace that I showed you here. So let's take a look at this. So here we have delete a message. How did it know from inside ECS that it had to add this to the trace? So this is going to be in here in this main.py. Like I told you, we have first to patch the X-ray. We do that using AWS X-ray SDK core. We configure a plugin to use ECS over here. After that, let's go over here. This is the background runner, which we saw. Let me show you the service map again. Sorry for the back and forth. Let's go to the service map. This is the background runner. Now you can see that I have a 5-minute filter. So right now, the background runner is the only thing that is doing a job, because there are no requests, and it's taking on average 20 seconds. If we increase the time or we make a call, then we get to see more data, such as the entire X-ray trace over here. So that background runner, you can see you have the name here, background runner, which matches what you have in the code, background runner. When I begin the segment, so you begin the segment, you do the SQS pooling. So I'm doing the maximum time that you are allowed to do a long pool. Once it gives you an array of messages, you can do another segment, which is the process message, which we also have on the map. Then you can do, this is something you have to do for you to have this map right here, for you to be able to connect what's coming from a serverless stack to a server full stack, which is ECS. You have to take the AWS trace header, create an instance using trace header.from header string, and then you have to set this segment using as parent the trace header that you got from SQS. So once you do all those steps, you get the full trace. And here I was able to put the annotation. Here I was putting the metadata that we saw, the hello that we sent. And here you can see we're doing a message.delete. And this is when we delete from SQS. And at this point, we don't need to do any X-ray specific configuration. As long as you have a segment open, which we have here, it's going to know where to send and how to connect the trace. And that's what we do here. Yeah, I think that's that answers your question.
Awesome. Thank you. Thank you.
Great. Any other questions?
Yes, I have a couple. Let's start from the easy
Awesome.
one. What do you think is SST is compared to SAM, Amazon SAM, and to serverless? If you see an improvement, because it's similar to those other frameworks to build lambdas. I found this SST to solve a lambda issue, and now I see that it grow much more and it provides a lot of other functionalities. I think it started this project with kind of an alternative to serverless framework, and now it's much bigger.
Yeah, it's been a while since I used the serverless framework. At the time, I had issues to like share resources from one stack to another. I don't think it was more a fault of the technology. I think at the time it was more like the team knowledge for that specific tool. So I think today all the tools they're pretty robust, and they are to a point where they offer good tooling. What makes me personally invest a lot into CDK and SST is being able to use a language such as TypeScript, which I know very well and has many features, such as, for example, you can set linting rules. You can even create tests for your CDK code. So you can go from, like with SST, you can do very basic, simple, and quick prototypes, and using the same code base, expand into something very robust and very scalable. And it also solved the issue that I had in the past with serverless, which is how do I share resources among stacks? I found a way to do using SST and CDK, which is to have an exporter stack, an importer stack using the parameter store, passing the ARNs to one stack to another. And as long as you don't create like a bidirectional relationship, you always make them go into a single direction. Like one place is responsible for exporting, this place imports, but never the other way around. So you never create a circular dependency between the stacks. This way you can scale to multiple microservices. You can have like a stack that creates a bus into an AWS account that gets imported into different AWS accounts that have their own stacks, and use the parameter store to import the bus and communicate via event-driven architecture using very clear language constructs with CDK especially. And yeah.
Exporting and importing stack, it means like you create a Lambda function, that Lambda function use a DynamoDB, and then you use another Lambda function that uses the same DynamoDB. So basically you define into one stack and then export it, and the second stack is not going to define it, it's going to import it, right? That is kind of the mechanics.
Yeah, so I found there are two to do importing, exporting. Let me show you. Let me see. I don't think I have in this demo. I have in a different project, so I won't be able to show you. But using SST, using SST, there's a function called use. So use, you can say use networking into your stack, and you get the return of the stack. So if in the stack you return a VPC and you use in another stack, you basically can use the VPC as if, and you don't need to care if you created another AWS account created. You don't need to care the origin. You get a clear interface, but that only works if you're in the same repository. If you are across repositories, the way I found to share was using the parameter store. So in this way, you need to create using kind of a name convention, a parameter, and into the other repository, you follow the same name convention to import. Another cool feature that you get by doing that is in this stack that is importing, if the dependency has not been created yet, you get an error before you are allowed to deploy. So you don't get the question like, do I have all my environment variables set up? Do I have all my dependencies? Which is a question that you easily have when you have many repositories. With SST and CDK, you can actually code in a way that you're not even allowed to test your application to deploy unless all the dependencies are met, which should also be a killer feature. I forgot to put in the beginning. But yeah.
Yeah, awesome. And the second question is, you showed an architecture infrastructure diagram at the beginning of the meeting. Yes. And I assume that you, what was shocking to me is like you create all that with SST, or you expanded with CDK to reach that level of detail. Yeah. Or detail or functionalities, because I checked the really fast SST and they provide like DynamoDB, SQS, Lambda functions, but I think they don't provide ECS cluster, right?
Exactly. They don't. With SST, you only get level 3 CDK constructs, which they, I think level 3 and level 2 constructs, which is like only serverless. That's what you get. For you to extend and have an ECS cluster or an Aurora cluster or a VPC, such as I did, then you need to extend with CDK. But it's, what can I say? It's really transparent because this stack that you get over here can speak with CDK. So maybe I can show something related to that. Oh, in fact, there was something very interesting here. You can see this right here, AppSync API. This is an SST construct. So it's using SST, but because I needed to do something more advanced, which is to connect AppSync with a Lambda authorizer, I had to say CDK and then extend using here the CDK logic. So I did that. And that's how you can use SST together with CDK. And from here, you can even go to raw CloudFormation. So you can go very, very deep if you want, or you can just stay in the SST land in the beginning of the project, which is much simpler, right?
Last question.
Let's go.
Do you see like SST to build an entire project, or just kind of solve some Lambda function stuff or some side workload from? So do you see to create like entire project, like API endpoints, Lambda functions, and everything with SST and extending with CDK?
Yeah, so I think today where CDK stands, it's a production ready tool. Companies use, I've watched, so I say this from the AWS events that I watched. In many of those events, the people that work in AWS services or work in CDK services, they share where the tool is at. And from what I saw in those presentations, CDK is very mature as an infrastructure as code tool today. In SST, at first I was cautious because I was afraid to use SST and like lose all the good things that I've been using with CDK. But then I saw that SST is just an extra layer on top of CDK that makes things much nicer, such as giving you Lambda debugging and some other like developer related features that I like. So I don't see a risk even for projects that have lots of developers, that have developers and DevOps together. I think it's an interesting tool to at least to start playing with and gaining experience. And at the same time, I think companies are already using CDK for many years and without many risks, considering that at the end, it's just CloudFormation, which is a very stable AWS service.
Okay, great. Thank you.
Thank you. Thank you for your questions. So that was pretty great. I appreciate a lot for you joining today. This is going to be on YouTube, so if you liked, please make sure to follow and give it a like. Bye-bye.
Right. Thank you. Bye-bye.
Bye. Thank you.
Thank you.